Okay, let's have a little talk here about finding x and y-intercepts for rational functions. And as you can see, I have 5 rational functions here, and we're just going to go through each of them and find the x and y-intercepts and kind of look at how to go about doing that and the different cases that can occur. So let's start with our first one here. We have y equals x minus 4 over x plus 3. And we'll start by finding the x-intercepts. Okay, so what are x-intercepts? They're points on the x-axis, the points where the graph hits the x-axis. Now think about this for a sec. Every single point on the x-axis has something in common, and that is every single point on the x-axis has a y value of 0. So to find the x-intercepts, all we need to do is set y equal to 0 and solve. Now let's take a look what happens when you do that. So we can say for x-intercepts, we need y equals 0. So therefore, this is going to be 0. So I'm just going to say 0 equals x minus 4 over x plus 3. Now, how would we solve this? Well, one thing we might do is get rid of our denominator, and we can do that by multiplying both sides of the equation by x plus 3. Now, here's the nice thing that happens when you multiply the right side here by x plus 3. You get rid of that denominator. It divides out, so you're left with the numerator of x minus 4. When you multiply this left side by x plus 3, you still get 0 because 0 times anything is still 0. And that tells us right away from this little equation that x has to equal 4. Okay? Now, you have to be really careful here. X equal to 4 will indeed make the numerator here work out to 0. And when it does that, you end up with 0 over something here, whatever that is. And as you know, 0 divided by something is 0. That's why it worked out. Now you do have to just double check that this value doesn't also make the denominator 0, because if it made this work out to 0, now we're talking about dividing by 0. And as you know, that is a big problem. Now, lucky for us here, it doesn't. 4 plus 3 would give us 7. But you should be checking that just to make sure it's not a problem. Okay, and you might have picked up on something. Notice that our denominator here just kind of disappeared because we multiplied it up by this 0 here. So is it safe to say that when we're looking for x-intercepts, really what we're interested in is what makes that numerator work out to 0? And the answer is yes, absolutely. Just look at that numerator, figure out what makes it work out to 0, and that'll make your entire function work out to 0. The only thing you got to be aware of is that it doesn't also make the denominator work out to 0. So double check that. Okay, so let's move on to the y-intercepts. So for y-intercept, you're going to have x equals 0. And this is a nice, easy calculation. You just take that, that equation here, and you are going to just sub in 0 for x. So we'll have y equals 0 minus 4 over 0 plus 3. And of course, that's negative 4 thirds. So your x-intercept is 4, and your y-intercept is negative 4 thirds. And that's it. Okay, so let's move on to the next one, and we'll do the same thing. Now, a really good thing to get in the habit of doing here is to factor right away. Now, all of the equations that I have here, all of the functions, I should say, are in expanded form. They're not factored. Sometimes you might get them in factored form, which is a little bit of a plus, but we're going to go and factor this right now. Makes it really easy to see the values that make things work out to 0. So upstairs there we get, we're going to have x plus 3 and x plus 4. And down here it looks like we'll probably have 3x and 2x there. And we will also probably have, well, we have a 2 there, so you're going to have a 2 and a 1. I'm assuming that you're comfortable with factoring. And we're going to want to have 4x minus 3x. So it's going to be that. So now that it's factored, we can go and find our x-intercepts. And this time, we are going to not write out all of this stuff because we're going to get some shortcuts here. We've already kind of picked up on those. So let's talk about x-intercepts. X-intercepts. And we're just going to go right to the answer. How are we going to do that? Remember, for the x-intercepts, we want this to work out to 0. And how's that going to happen? Well, normally, we'd go to solve this little equation. We multiply by this. But when you multiply that by 0, it kind of just disappears because it's 0. And you're left with this equal to 0. And then you can just say, well, what would make this work out to 0? And because it's factored, you can tell right away, -3 coming from this bracket or -4 would make it work out to 0. So the trick is just look at the numerator. And what makes that work out to 0? That's going to be your x-intercepts. So x-intercepts here will be -3 and -4. Okay, so I'll write that, -3, -4. But remember what I said before. Just do a quick double check that these values don't also make the denominator work out to 0. Okay, because if they do, then you're going to have a problem, and that problem is division by 0. Okay, so I'm going to get rid of that there for now. That was it. Now for the y-intercepts, it's actually really nice that this is in unfactored form here, because all we're going to do for the y-intercept is, as we did before, we're going to make x 0. And when it's not factored, it's great because anything that has an x is just going to work out to 0 when you sub in 0. So you'll be left with 12 divided by -2. Okay, and that is just going to give you -6. So see how quickly we can do that if we use the unfactored form. Of course, you can use the factored form and sub in 0 for x. It'll just take a little bit longer to do some multiplying and dividing. Okay, moving on to the next one here. Well, let's do what we did before. We'll factor. Upstairs you have a difference of squares, so you'll have x plus 4, x minus 4, over, looks like we can common factor down there a 3x. That'll leave us with x minus 4. Now, for the x-intercepts here, be careful. We get in the habit of saying, well, if it makes the numerator work out to 0, it's going to be an x-intercept. So you might think that the x-intercepts are -4 and +4. But wait, they're not. Okay, why not? Because if I had +4 here, right, that makes this work out to 0. But the problem is it also makes the denominator work out to 0, which means we're dividing by 0. You can't do that. So you don't actually have a point at an x value of 4. You can't do that because it creates a division by 0. So what is happening there? Well, it's actually something called a hole, and we'll talk about that in another video. Check out the video on vertical asymptotes and holes. But for now, we only have, all we can say here is we have one x-intercept, and that is -4, which is coming from that bracket working out to 0. Okay, now what about the y-intercept? Well, let's see here. If we sub 0 in for x, what do we get? Well, then this would work out to 0, this would work out to 0, this would work out, that denominator works out to 0 if you sub in an x value of 0. So you'd have like -16 over 0. Well, you can't divide by 0. So what does that say about the y-intercept? There is none. Okay, now what is happening there? It's actually a vertical asymptote. So again, check out the video on vertical asymptotes and holes if you want to see more on that. All right, moving on here. This is an interesting one. It looks like it would be simpler, but it's kind of weird. You go to find the x-intercept. We don't even have to factor here. And we can kind of take our usual approach and say, what makes the numerator work out to 0? Well, the numerator is 8. That's never going to work out to 0. And if you think about it, no matter what you sub in for x here, you'll never get this expression to work out to a y value of 0. Right? It just won't happen. You can put in huge values of x and you'll get values close to 0 for this result here, but it'll never actually hit 0. So that's telling us that our x-intercepts don't exist. There are none. Okay? And for the y-intercept, we can sub in the x value of 0 right here. That'll give us a result of 8/7. Okay, and one more to go here. This is kind of an interesting one. This comes up frequently and kind of causes some confusion for students. For this one here, to find the x-intercepts, we can take our approach of saying we want the numerator to work out to 0. Because when you set it equal to 0 and multiply the denominator through, the denominator disappears and you're essentially left with the numerator equaling 0. So for the x-intercept, you might say, okay, well, I need x squared plus 4 to work out to 0. Now notice I didn't try to factor this right away. Why didn't I do that? Because it doesn't actually factor. How do I know that? Well, square anything you want. If you add 4, you're not going to ever get 0. I mean, if this was a difference of squares, it would factor. But I didn't even bother trying to factor it because I know if you square something and then add 4, there's no way you could get 0. That's why I didn't even factor it at all to begin with. And you can see that here. If you tried to solve this, you'd end up with x equals plus or minus the square root of negative 4. Well, square root of negative 4, not going to happen. So there are actually no x-intercepts. Okay, it looked like there might have been, but that doesn't factor, and we know right away it doesn't equal 0. So no x-intercepts. All right, and what about y-intercepts? Okay, subbing your x value of 0, that's 0. This works out to 0, so you get 4 over negative 2, which is negative 2. And that's it. So a few things to keep in mind. Factor, and when you're looking for the x-intercepts, look for what makes the numerator work out to 0. Just double check that it doesn't also make the denominator work out to 0, because if it does, it's not an x-intercept. And for the y-intercept, just sub 0 in for x. I hope that helps.